All right, students, welcome back to our 7.5 video lesson. This is number 2 uh, on continuing these properties of logarithms. So I'm going to review here the properties of logarithms that we used last time, and mainly these three here, the product, quotient, and the power rule. So with the first assignment, you were taking a single log and breaking up into multiple logs, so basically going left to right with these properties. Now, in this assignment here, it's going to give you multiple logs and you want to write each expression as a single logarithm. So I'm going to be going in reverse. I'm going to be going right to left, taking two logarithms here and combining them into a single logarithm, or taking a number in front of a log and bringing it up as an exponent. So I'm basically just taking exactly what you did in example 2 last time and doing reverse. Instead of going this way, we're going exactly, again, all those steps in reverse. From here, we're going to go backwards. Okay, so you may wonder why we're doing that. Well, just that's how logarithms work. Sometimes we want to write it as a single logarithm. It's easier that way. Sometimes we want to take a single logarithm and break it up. Okay, so we want to be able to be comfortable going both ways with it. So here we go. Let's look at this first example. Write each expression as a single logarithm. So we're going to basically do what we did, like I said, we're going to do what we did last time in reverse. So if you remember previously, the last example we did was the power rule. So now that's going to be the first rule that we did. We're going to use as the power rule. We're going to take the 4 and the 2 and write them up and the exponent of the base. So log of x to the 4th plus log of y to the 2nd. And notice these are base 10. That still says base 10. All right. Once I've done that, now I'm going to say a sum of logarithms. We know inside a log becomes a product. So it's going to be the log of the quantity x to the 4th times y to the 2nd. Okay, and make sure you put a parentheses there just so that you know what product is inside the log. And we're done. That's it. So that's all I have to do, right, as a single logarithm. So like I said, we're just doing the same rules we did last time, just in reverse. Any number in front of the log becomes an exponent, and adding becomes a multiplying. Subtraction becomes division. Okay, so next one. 1/2 log base 5 of a minus 7 log base 5 of b plus 10. So let's take the 1/2 and the 7 and make them an exponent. So log base 5 of a to the 1/2 minus log base 5 of the quantity b plus 10 to the 7th power. Okay, and now since it's a subtraction, I'm going to make it division. But remember, it's division inside a log. It's not two different logs. The division happens inside a single log. So log base 5 and then parentheses a to the 1/2. Now, anytime you have a exponent that's a fraction, I want to see you write it as a radical, just for practice. So a to the 1/2 we know is the square root of a, and then b plus 10 to the 7th power. That's all inside the log. Okay. Side note: do not try to distribute that 7. Remember, you can never, ever, ever distribute an exponent. Okay, so just leave it as b plus 10 to the 7th power. All right. So before we move on, a little hint on these. Look at the instructions again. Write your answer as a single logarithm. What that means is look at in our answer. How many times do you see the logarithm? And you should say one time, right? There's one log there, one log there. That's what that means, a single logarithm, okay? So like I said with part B, do not write it as log base 5 of this divided by log base 5 of that, right? That's two different logs. The multiplication or division happens inside a single logarithm. Just remember that. Okay, next one. Part C. I've got a sum here and a difference. So I'm going to do multiplication and division. So once again, first I'm going to bring the exponents up. So ln of 5 to the 2nd plus the ln of z to the 6th power minus the ln of y squared plus 4 to the 1/3. Okay, so now write a single logarithm as always. So ln inside the logarithm, the 5 squared and the z to the 6 are added. The logs are added, so inside they are going to be multiplied. Now always simplify a power if you can, right? 5 squared, of course, is just 25. So 25 times z to the 6, and then the subtraction becomes divided by. So y squared plus 4 to the 1/3. Like I said above, always take a fraction exponent and write it as a radical. So that's the cube root of y to the 2nd minus 4, and we're done. That's inside it. So one more time, you have the natural log of 25z to the 6th divided by the cube root of y squared minus 4. Okay. Um, Last one here. I also have a addition, subtraction, but the order is different. It's subtraction first and then addition. But guess what? That doesn't really matter, and you'll see why when we're in a moment here. So first thing we do, bring up the exponents. Log base 2 of 10 to the third minus log base 2 of n to the fourth plus log base 2 of m to the ninth. So now these two logs are subtracted, so it becomes division. This is added, so it becomes multiplication. So um, you might first write it like this. Write your division. So 10 cubed is 1,000 divided by n to the fourth, and then multiplication times m to the ninth. Okay, but let's look at that again in here. I have 1,000 over n to the fourth times m to the ninth. Anytime I'm multiplying a fraction um, by a number, by a power that's in with a positive exponent, that's in the numerator, right? So I can just multiply the m to the ninth by the 1,000, and I can make it look like this: 1,000 m to the ninth all over n to the fourth power, and that looks a little nicer. So back to here, look what happened. It didn't matter that the addition was after the division, or I'm sorry, the addition was after the subtraction. Subtraction, this term being subtracted meant that the n to the fourth was in the denominator. This log being added meant that the m to the ninth was in the numerator. Here we had adding, then a subtracting, but both these were the numerator, this was the denominator. Here we had subtracting and adding, didn't matter. Any log that's positive or being added, that factor ends up in the numerator. Any log that's negative or being subtracted, that factor ends up in the denominator. All right, that's a very important rule I want you to think of. Doesn't matter how many logs there are that are added, doesn't matter how many are subtracted, doesn't matter what the order is. So one more time, I'll say it again. Any log that's positive or being added, that factor inside the log ends up in the numerator. Any log being subtracted, that factor ends up in the denominator. And let's say both of these were negative, both these were subtracted. What that would mean is that both of these n to the fourth, m to the ninth would be in the denominator. Now that's not the case here, but I'm saying if it was, if you have multiple logs being subtracted, then you have multiple logs in the denominator. Okay, so that's the rule there to write as a single logarithm. Last thing before we're done, you're going to need a calculator for this once again. The change of base formula on your calculator. You remember from 7.4, we did common logs and natural logs on your calculator. Any calculator, scientific, graphic, your phone, whatever, usually has two buttons, one for common log, one for natural log. Well, what if you have to do a logarithm of another base? Base 2, base 3, base 5, base 12, whatever, anything but e or 10. Then how do we do it? Well, there's a very simple change of base formula to take the log of any base b and change it to either common log or natural log so you can use your calculator. And here it is. The log base b of m, first let me use the common log, is the common log of m over the common log of b, okay? Or if you like the natural log, guess what? You can use the natural log. Same thing. Natural log of m over the natural log of b. And guess what? It doesn't matter which one you use. They're both the same value. This ratio and this ratio are the same, okay? So it doesn't matter if you like common log or natural log. It's just the log of this number divided by the log of this number. So here's what I mean. Suppose let's evaluate log base 7 of 20 and get out your calculator to do this. Once again, you can choose either common log or natural log. I like natural log better, so I'm going to use that. It's the natural log of 20 divided by the natural log of 7. Notice it's not the natural log of 20 over 7, right? That's different. It's the natural log of 20 divided by the natural log of 7. Do that in the calculator, and you get 1.5395 approximately. Okay? And before we leave real quick, let's check your answer. How would we check that? Well, ignore this middle part for a moment. Think back to 7.4. How do we change a log to exponential form? This base to this power equals this number. So do that in the calculator now. Do 7 to this power, and you get 20, or a number very close to 20 since you rounded that. And that's how that works. So that's how we can evaluate now logarithms with any base. Okay, so that's the second part of your 7.5 homework. Is going to be right here. It's going to be just practicing taking a multiple logs and writing as a single logarithm. So on your 7.5 homework, please do number 33 through 49 odd and share that with me. And then after you get both those assignments done, there's a review sheet to finish up 7.5 on logarithms.